Hi friends, good afternoon. Today we are going to discuss with another section of differential equation. In previous classes we seen solution of different kind of differential equation. Now here we are going to approach the solution of a differential equation based on a series solution, right? Based on a series solution. See, in series solution method, what I have to do, consider differential equation, higher order. Usually we deal with a higher order differential equation. So many methods we have studied to solve a higher order differential equation. So say a higher order differential equation, say d square y by dx square plus p of x into y dash plus q of x into y is equal to f of x. This is a higher order differential equation, right? This is a second order higher order differential equation. To solve this, let us imagine the solution is y is equal to sigma n is equal to 0 to infinity n x raised to n, right? So we imagine this is the solution of this differential equation, alright. Now from this y, first I find a y dash, then I find a y double dash. That value we substitute here and then we solve the differential equation, right? So this is the method we are going to do. See, for example, suppose let us approach with an example. See, y double dash, suppose y double dash plus y equal to 0, right? This is a differential equation. Now how we solve this differential equation? We solve auxiliary equation. That is the method we have previously studied, right? Auxiliary equation, what? M square plus 1 equal to 0, then m square is equal to minus 1, then m is equal to plus or minus I. If our auxiliary equation solution is a plus or minus IB format, what is the solution of the differential equation we studied? We studied that the differential equation is e raised to ax into c1 cos x plus c2 sin x, right? Now let us look into c1 cos bx plus c2 sin bx, right? Now for the particular solution m, what we got is 0 plus or minus I. Then what is a is 0 here. Then solution is e raised to 0x into b also 1, coefficient of I is 1. Then c1 cos x plus c2 sin x, right? Now y is equal to, what I can write, c1 cos x plus c2 sin x, right? This is the solution of the differential equation, right? So c1 cos x plus c2 sin x. Now the same problem I am going to do with this method, right? Applying the solution I consider as a summation of a series terms, right? A summation of terms, and then finding y dash, y double dash and substituting here, then solving, we will get the same result, right? So let us do that. So let me take, right, see, look here. Here you can see, look, see here I considered the same equation, y double dash plus y is equal to 0, right? So here y is equal to, I am considering as a series solution, sigma n is equal to 0 to infinity n x raised to n, right? Now I am finding y dash from it, first differentiation, okay? Sigma n is equal to, by differentiating one time the n value increases by 1. Why? Because when n is equal to 0, here x raised to n. Now here n minus 1 only come, right? Then you have to put n is equal to 1, then only here x raised to 0 come. Here you put n is equal to 0 means x raised to 0 come. Then by differential, what happened? N value you increased by 1, right? Sigma n is equal to 1 to infinity, then differentiate a n x raised to n differential n x raised to n minus 1, alright. Now y dash you are finding, y dash. Now I am changing the value n is equal to 1 to n is equal to 0, right. Then what I have to do? I replace, if I am starting from n is equal to 0, I have to replace all the n with n plus 1, right. Then sigma n is equal to 0 to infinity a n plus 1 n plus 1 x raised to n, right. Now again I am finding y double dash, right. How I find y double dash? By differentiating, again differentiating n changes to 1. Sigma n is equal to 1 to infinity, here a n plus 1 is there and n plus 1 into, right, n plus 1 into x raised to n, again doing n x raised to n minus 1. Now I want to change again n value to 0, then I am replacing all the n into n plus 1, right. Then if I put n is equal to n plus 1 only, here x raised to n come, right. So by increasing the index value by 1, all the term increases, all the n value increases by 1, alright. So y double dash is equal to sigma n is equal to 0 to n is equal to 1 changes to n is equal to 0. Then all n changes to n plus 2. Then n plus 1 is what? N plus 2. Then a n plus 2 plus n plus 1 plus 1, that is n plus 2, n changes to n plus 1. Here n plus 1 minus 1, that is x raised to n, right. Now you solved y dash value and here you solved y dash, y double dash, all the value you solved, right. Now what is the next step? We are substituting this y double dash and y in the starting equation, right. Now I am going to substitute that here. Look, see, here sigma n is equal to 0 to infinity. See, look here, a n plus 2 n, say a n plus 2 n plus 2 into n plus 1 into x raised to n plus y value, the same equation, y double dash value substituted. Now y value is this, sigma n is equal to 0 to infinity a n x raised to n equal to 0, alright. Now a n plus 2, what I can write? This all common term we can take to that side 0, then finally I can write a n plus 2 is equal to this, a n go to this side minus a n by this n plus 1 and n plus 2 come down, n plus 1 n plus 2, right. Now put n is equal to 0, n is equal to 0, you get a2, a2 is what? A0 divided by, right, put a 0, 1 into 2, that is 2. Say a0 I am taking as c1, one constant is c1, then minus c1 by 2. Now put a n is equal to 2, then you get a4, a4 is equal to, see, put n is equal to 2 here, right, n is equal to 2 here means 2 plus 2 4, then minus a2 divided by 2 plus 1 into 2 plus 2, 4 into 3, right, then minus a2 by 3 into 4, then what is, right, a2 already we solved, a2 is minus c1 by 2, then minus of a2 is minus c1 by 2 substituting here, right, then what, this 2 here, then this 2 not required, minus plus, then 4 into 3 into 2, that is 4 into 3 into 2 is 4 factorial, then plus c1, minus become plus, c1 by 4 factorial, right. Now generally what I can write from this, what I understood, see, a2 minus c1 by 2, a4 c1 by 4 factorial. Generally a2n you can write as minus 1 raised to n c1 by 2n factorial. If you put n is equal to 1, you get minus c1 by 2, right. If you put n is equal to 2, you get a4, right. Now similarly put n is equal to 1 in this expression, then you get a3. a3 is n is equal to 1, put a minus a1 divided by 3 into 2, right, 3 into 2, that is 3 into 2, and say a1 is another constant c2, then minus c2 divided by 3 into 2 is 3 factorial. Now n is equal to 3, put n is equal to 3 here, 3 plus 2 5, then minus a3 divided by 5 into 4, right, here 5 into 4, right, n put 3 plus 2 5, 3 plus 1 4, then 5 into 4 minus a3, right? Now what is a3? A3 value is minus c2 by 3 factorial, right? Minus c2 by 3 factorial. That minus c2 by 3 factorial I am substituting here for a3, right? Then minus a3, right? Here minus is there, a3 minus c2 by 3 factorial, then c2 by 3 factorial, then c2 by 5 into 4 into 3 factorial, c2 by 5 factorial. Then odd values a3, a5 generally I can write as minus 1 raised to n c2 by 2n plus 1 factorial, right? Suppose you put a n is equal to 1 here, right? N is equal to 1 here means you get a3, right? Then a3 means minus c2 by 3 factorial, that we already get, right? So like this, generally what I can write, a2n is this, a2n plus 1 this. Now I am going to substitute these values in the series solution, okay? Alright, so let me go to next step. So what is the general solution by this method we studied? Y of x is equal to sigma n is equal to 0 to infinity a n x raised to n, alright? So y is equal to, now put n is equal to 0, 1, 2, 3 etc. summation I am writing. A0 x raised to 0 is 1, then a0, next one is a1 x raised to 1, a2 x square, a3 x cube plus a4 x cube, right? Now a2n generally we derived this, a2n plus 1 generally we derived this, right? So from this I can find a0 value c1, a1 value, right? a0 value c1. What is a1 value? Put n is equal to 0 here, right? Then a1 value is, n put 0 means c2 divided by c2, right? Then a0 is equal to c1, a1 is equal to c2. Now a2 finding, what you have to do? Put n is equal to 2 here, then square c1 by 4 factorial, c1 by 4 factorial, that is a4, right? To find a3, what you have to do? Put n is equal to 1, n is equal to 1 means minus 1 minus c2 divided by 3 factorial, right? And a5 similarly you can find, put it n is equal to 2 here, then a5 you are getting, that is c2 by 5 factorial. Now putting this a0, a1, a2, a3 value here, right? Then what you can write? C1 plus c2x minus c1 by 2 factorial x square. So here c1, right? a0 is c1, a1 is c2, right? a2 is minus c1 by 2 factorial x square, a3 is minus c2 by 3 factorial x cube, a4 is plus c1 by 4 factorial into x raised to 4 etc., right? Now what I am going to do, y is equal to c1 you can take out, c1 here after c1 is 1, here minus x square by 2 factorial, now here 1 c1, then x raised to 4 by 4 factorial etc., plus c2 into, right, c2 taken out, here one x is pending, that is only x, and here c2 going means x cube by 3 factorial, right? And here c2 going means x raised to 5 by 5 factorial. Now look into this. This series is as per Taylor expansion series. This is what? This is cos x 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by, right, 6 factorial, that is representing cos x, right? And x minus x cube by 3 factorial plus x raised to 5 by 5 factorial plus etc., this is sin x. Then what you get? A y is equal to c1 cos x plus c2 sin x, c1 cos x plus c2 sin x. This only the previous method also same solution. By solving auxiliary equation, initially we told m square plus 1 is equal to 0, m square is equal to minus 1, m is equal to 0 plus or minus I. Then solution is, this is a plus or minus ib format, then e raised to ax into cos x c1 cos bx plus, right, and c2 sin bx, right? Now put a is equal to, a coefficient is 0, then this part is 1 and b coefficient is 1 here, then cos c1 cos bx plus c2 c1 cos x plus c2 sin x, b value is 1, coefficient of phi is 1, right? So this is the method to solve a differential equation by series solution method, right? If series solution method, what is the importance? You may feel it is very tedious to calculate, but to solve certain kind of differential equation, the series method of solution is very necessary, like a Hermite polynomial, Legendre polynomial, Legendre polynomial, Bessel differential equation. This kind of special differential equation to solve, we can employ this series solution method only, right? Alright, in coming classes, we study what are the Hermite polynomial, Legendre polynomial, Legendre polynomial, etc. Okay, thank you.